This is SpaceTime, Series 23, Episode 27. Coming up on SpaceTime. Quasar Tsunamis seen ripping across galaxies. The Mars Curiosity rovers climb up the red planet's Mount Sharp. And a new Australian rocket engine successfully test-fired for the first time. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers using NASA's Hubble Space Telescope have discovered massive tsunami-like energy outflows from distant quasars tearing across interstellar space and wreaking havoc on the galaxies in which they originate. A report in the Astrophysical Journal claims these spectacular events could help answer some long-standing cosmological puzzles, such as why there seem to be so few large galaxies in the universe, and why there's a relationship between the mass of a galaxy and the mass of its central supermassive black hole. Quasars are powerful jets of energy streaming out from supermassive black holes being fueled by infalling material. They can shine 1,000 times brighter than the hundreds of billions of stars in their host galaxies. As the black hole devours matter, hot plasma encircles it and emits intense radiation, creating the quasar. Winds being driven by blistering radiation pressure from the vicinity of the black hole then push the material away from the galaxy's center. These outflows accelerate to superluminal velocities. The study's lead author Narum Arab from Virginia Tech says over the lifetime of 10 million years, these outflows produce 1 million times more energy than a gamma-ray burst. In fact, no other phenomena carries as much mechanical energy. The winds are pushing hundreds of solar masses of material each year. The amount of mechanical energy these outflows carry is up to several hundred times higher than the luminosity of the entire Milky Way galaxy. And the quasar winds plough across their host galaxy's disk. Material that otherwise would have formed new stars is violently swept away from the galaxy, causing starbirth to cease. The radiations pushing the gas and dust to far greater distances than scientists had previously thought, in the process creating galaxy-wide events. As these cosmic tsunamis slam into interstellar material, the temperature at the shock front spikes to billions of degrees, causing material to glow, largely in X-rays, but also widely across the entire electromagnetic spectrum. Arab says anyone witnessing such an event would see a brilliant celestial light show, first in a flood of gamma and X-rays, then invisible light, and eventually infrared radiation. It would be as if Christmas trees were lighting up all over the galaxy. Astronomers have long suspected that some sort of physical process is shutting off star formation in massive galaxies, but the nature of that process has been a mystery. Now, putting the observed outflows seen by Hubble into computer simulations solves these outstanding problems in galactic evolution. The authors studied 13 quasar outflows. They used spectroscopic Doppler measurements to determine the speeds at which the outflowing gas was being accelerated by the quasars. Aside from measuring the most energetic quasars ever observed, the authors discovered one outflow which was accelerating faster than the others. In fact, it increased from nearly 70 million kilometers per hour to roughly 74 million over a 3-year period, and scientists believe its acceleration will continue to increase over time. The study also showed that these powerful quasar outflows should be prevalent throughout the entire early universe. You're listening to SpaceTime. Still to come, the Mars Curiosity rovers climb up the red planet's Mount Sharp, and later in the science report, a new study shows 95% of COVID-19 deaths could have been avoided. All that and much more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by Tech Radar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
NASA's Mars Curiosity rover is preparing for the next stage of its ascent of Gale Crater's Mount Sharp. Curiosity's been climbing the crater's central peak since 2014. Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, say there are several regions on the mountain which are intriguing scientists. Chief among them is what the science team are calling the clay-bearing unit, where Curiosity's been analysing rock samples. Others include the rocky cliffs of the so-called sulfate-bearing unit, where sulfate minerals might indicate the area was drying up or becoming more acidic in ancient times. This includes the Gadiz Vallis, where a river is thought to have carved a path through the sulfate unit. Each of these regions represents a different period in the history of Mount Sharp, which rises some 5 kilometres from the floor of Gale Crater. Curiosity scientists want to visit these places to learn more about the history of water on the mountain, which slowly dried up as the red planet's climate changed. Understanding how these changes occurred on Mount Sharp may provide new insights into why water disappeared from Mars billions of years ago. The car-sized Mars Science Laboratory Curiosity rover has been exploring the red planet's Gale Crater, searching for signs that Mars was once habitable, with the sorts of conditions and environments that could have supported life. Launched aboard an Atlas V rocket back on November 26, 2011, from the Cape Canaveral Air Force Station in Florida, Curiosity successfully touched down on the Martian surface on August 6, 2012, following a 560 million kilometre long journey. The landing site, just south of the Martian equator, was the Aeolus Placis, a vast plain between the northern wall of Gale Crater and the northern foothills of Mount Sharp. The 154-kilometre-wide Gale Crater was named after Walter Frederick Gale, an amateur astronomer from Sydney who studied Mars in the late 19th century. The 3.8 billion-year-old crater was selected as a potential landing site because it shows evidence of being a dry lake bed, with signs of an outflowing channel carved by running water, and also because Mount Sharp appears to have a layered geological structure, thereby allowing scientists to read its mineral history like a book. The 899-kilogram six-wheel rover spent its first 2 years on Mars exploring the region around the landing site, quickly achieving its primary mission by identifying the dried-up remains of local lakes and rivers, thereby confirming that Mars once had both standing and flowing water, essential for life as we know it. The rover's meandering path, stopping off at any interesting rocks or formations, saw it reach the foothills of Mount Sharp in September 2014. Curiosity is powered by a radioisotope thermoelectric generator, which produces power through the decay of radioactive isotopes of plutonium-238. It uses 2 identical radiation-hardened onboard computer systems and 4 sub-processors. The rover is equipped with a significant telecommunications redundancy, including an X-band transmitter and receiver to communicate directly with Earth, and 2 UHF radios to contact orbiting spacecraft, which can then act as relay satellites. Its scientific instrument package uses 17 high-resolution cameras, including 8 HAZCAMs, 4 NAVCAMs, 2 MASTCAMs, and 3 specialist instrument cameras. Curiosity is equipped with a 2.1-metre robotic arm with 3 joints, allowing it to move and manipulate instruments and samples. It carries 5 devices, including an X-ray spectrometer, a Mars hand lens imager, a percussion drill, mechanisms for scooping, sieving and proportioning samples of powdered rock and soil, and a dust removal tool to clean samples before close-up imaging. The robotic arm's alpha particle X-ray spectrometer irradiates samples with alpha particles and then maps the spectra of X-rays that are re-emitted to provide detailed elemental composition analyses of samples. The robotic arm's Mars hand lens imager camera provides ultra-high-resolution microscopic images of rock and soil samples with both white and ultraviolet LED illumination for imaging in darkness or for fluorescence imaging. Other scientific instruments include ChemCam, a laser-induced breakdown spectrograph which provides elemental compositions of rocks and soil, and a remote microimager to provide high-resolution images of the sampling areas of the rocks and soil, targeting samples up to 7 meters away, vaporizing a small amount of the sample with nanosecond pulses from an infrared laser, and then undertaking a spectra of the light emitted by the vaporized material. Curiosity also uses 2 pairs of navigation cameras mounted on the mast to support ground navigation, providing a wide-angle view and stereoscopic 3D imagery. The rover's environmental monitoring station has a suite of instruments designed to measure the Martian environment, including humidity, air pressure, air temperature, wind speeds, and ultraviolet radiation. The meteorological package sensors are located around 3 elements: 2 booms attached to the rover's mast, the ultraviolet sensor assembly located on the rover's deck, and the instrument control unit inside the rover's body. The rover also has 4 pairs of hazard avoidance navigation cameras, 2 at the front and 2 at the rear. Known as HazCams, they provide wide-angle stereoscopic views for autonomous hazard avoidance during rover drives, and for positioning the robotic arm on target samples. Then there's the chemistry and mineralogy instrument suite, which analyzes organics and gases from both atmospheric and solid samples. It includes a gas chromatograph and tunable laser spectrometer to undertake precision measurements of carbon and oxygen isotope ratios in atmospheric carbon dioxide and methane in order to determine if they're of geochemical or biological origin. So far, they've all been geochemical. There's also a radiation assessment detector. It was used to characterize the broad spectrum of radiation which found its way inside the spacecraft during its cruise phase from Earth to Mars, and it's now being used to monitor radiation around the rover on the Martian surface. These measurements are important because they'll help scientists develop spacecraft shielding for future manned interplanetary missions. There's also a dynamic albedo of neutrons instrument, which uses a 14.1 millielectron-volt pulsing neutron generator and detector to measure hydrogen or ice and water at or near the Martian surface. Finally, there was the Mars Descent Imager, or MARDI, which was mounted on the rover's body and used to film the descent to the Martian surface, map the surrounding terrain, and also provide an exact location for the landing. Curiosity's design has been so successful, it's been replicated on NASA's next Mars rover mission, initially called Mars 2020, and now recently renamed Perseverance. If all goes well, it'll be launched in July. This report on Curiosity's journey up Mount Sharp from NASA TV.
For almost 7 years, NASA's Curiosity rover has been exploring Mars. The rover is climbing a mountain, Mount Sharp, that is dry and sandy today. But 3.5 billion years ago, rivers, lakes, and groundwater could be found here. Curiosity recently entered a valley between a ridge and cliffs higher up the mountain. We've been calling this area the clay unit because Mars orbiters have seen a strong clay signal here. That's exciting because clay minerals often form when water is around. From the ground, we can look for clues of ancient water. In these cliffs above the clay unit, the same orbiters see sulfate minerals. That could mean that water was drying up or becoming more acidic. Comparing the clay and sulfate layers could give us a better idea of how the Martian climate changed over time. Cutting through the sulfate layer is evidence of an ancient gushing river, Geddes Vallis Channel. In orbiter images, we've seen boulders and other debris that were probably washed out by the river. This channel formed after the clay and sulfate layers. It's a whole other chapter in the story of water on Mount Sharp. These features could teach us about more than just the mountain. They may help explain what changes were happening across Mars at the same time, and how that affected its ability to support life, if it ever existed here.
Well, after spending almost a year trying to get the drill aboard NASA's Mars InSight lander to work, mission managers have finally fixed the problem the old-fashioned way, by giving it a good bash with a shovel. The drill is part of the heat flow and physical properties package better known as the mole. The 38cm probe is designed to dig down some 5 meters into the Martian soil, providing scientists with internal Martian heat measurements from deep below the red planet's surface. But almost as soon as it started to dig, it suddenly stopped, and repeated attempts over the past year to try and get it going again have all failed. Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, and the Heat Flow Science Package engineers from the German space agency DLR, which built the technology, couldn't work out if the problem was the Martian soil being too sandy for the mole to get a good grip and start drilling down, or whether it simply hit a big rock just below the surface. But try what they liked, nothing worked. So, finally someone suggested forcing it with a scoop on the lander's robotic arm. And lo and behold, it seems to have worked. Fingers crossed. Sometimes you've just got to rely on the old tried and proven methods, although I probably would have wound up using a hammer. The 358-kilogram InSight lander was launched aboard an Atlas V rocket from the Vandenberg Air Force Base in California on May the 5th, 2018, landing on the red planet's windswept Elysium Planitia on November the 26th. InSight is studying the earliest evolutionary processes that shape Mars. It's looking at the size, thickness, density and overall structure of the Martian core, mantle and crust, and the rate at which heat escapes from the planet's interior. This data will provide scientists with a glimpse into the evolutionary processes of all the rocky terrestrial planets in the inner solar system. Meanwhile, another science package brought to the red planet aboard InSight has been measuring Martian earthquakes, or should that be Marsquakes? The French Space Agency's seismic experiment for interior structure seismometer is located on the ground some distance from the lander and under its own cover to protect it from the Martian wind and sudden atmospheric temperature changes. The experiment measured its first Mars quake on April the 6th last year. And of course it's not the first time quakes have been recorded on other worlds. NASA sent seismometers to the lunar surface aboard the Apollo missions in the late 60s and early 70s, and to Mars aboard the Viking landers in the mid-70s. Quakes look and feel very different depending on the material their seismic waves are passing through. The new data from InSight shows that Mars quakes fill in about halfway between those on Earth and those on the Moon, which is sort of good considering Mars fits in size-wise about halfway between the Earth and the Moon. InSight's seismometer is monitored by a scientist led by the Swiss research university ETH Zurich. After collecting the data, the scientists simulated a Martian quake in their shake room so they could experience it for themselves and then compare it to simulated tremblers on the Earth and the Moon. But they needed to amplify their Mars quake signals by a factor of 10 million in order to make the quiet and distant tremors perceptible in comparison to similarly amplified moonquakes and unamplified earthquakes.
The seismometer we have on Mars is fantastic. It's operating as well as we could have dreamed. It's exceeding expectations. The goal of InSight is to understand the structure of the planet of Mars. And the primary way that we're going to do that with InSight is by measuring Mars quakes. ETH Zurich is leading the international team that is checking all of the data as it arrives every day and trying to detect and pass on the information that Marsquakes have actually occurred to the science team. We're down here in the simulator room of the Swiss Seismological Service, and we're here today to show the first example of replaying the first events that we recorded from our seismometer on Mars.
So let's start with what we know, which is an earthquake. An earthquake from Switzerland takes 30 seconds and has very clear onsets, as we'll see.
So this Swiss quake, we'll start with the P wave that you feel there, and then in a few seconds we'll hear the S wave arrival. Slightly bigger. So that's the classic type of wave arrivals that we were hoping to see on InSight.
The next thing is one step more exotic, which is the moon. So we load a moonquake into our system and see how that feels.
This is the SP recording, so there's no...
Yeah, it's very narrow banded on that.
Yeah. Slowly getting bigger.
The signal is very different. We have a much smaller attenuation of the seismic waves, but at the same time we have a very strong scattering, which means that the shaking will go on for tens of minutes or maybe up to an hour.
Next thing we'll load into the system are the Marsquakes, which were discovered by the Marsquake service recently. We want to know how they feel on the scale between the Earth on one side and the Moon on the other side.
On Mars, we so far have seen two families of quakes, and so there's a higher frequency one, and this one that we experienced now was more the low frequency version. We think this is probably pretty far away. The motions that we have here are amplified by a huge factor so that we can even see them, because on Mars the amplitudes are extremely low.
Mars isn't as simple as we might have hoped. The ground motion is not like we see on Earth. It's sort of a halfway house between Earth and the Moon. We're really trying to put the various events in place. It's a big jigsaw puzzle at this stage, and we have a long way to go before we understand it, but it's extremely exciting at this stage.
And in that report, we heard from John Clinton, head of the Marsquake service at ETH Zurich, and Simon Shaler, Marion Bose, and Martin Van Drill, all seismologists from ETH Zurich. This is SpaceTime. Valiant Space has successfully test-fired its new locally developed liquid-fueled rocket engine. The commercially developed motor, called the Momentum Engine, is being developed to deliver commercial and scientific payloads to and from the lunar surface. The hot-fire test was undertaken at the Beyond the Blue Aerospace Launch and Test Facility, located just north of the western Queensland town of Goondiwindi. It follows a year of system development and inert propellant testing. The company will now work towards integrating the new engine into a launch vehicle capable of simulating lunar descent, landing, and traversing maneuvers. China has successfully launched another Bedao 3 navigation satellite into geostationary orbit. The mission aboard a Long March 3B rocket from the Xichang Satellite Launch Center in southwestern China's Sichuan province was the 54th Bedao Global Positioning System satellite to be placed into orbit. Bedao is designed to provide Beijing with an independent satellite navigation system for its ever-expanding military and national security forces. And it wasn't the only one sending navigation satellites into space, with Russia launching a new GLONASS-M navigation satellite. The spacecraft was launched aboard a Soyuz 21B rocket from the Plesetsk Cosmodrome, 800 kilometers north of Moscow. The new GLONASS-M will replace an earlier generation navigation satellite which has reached the end of its useful life. The Russian GLONASS global satellite navigation system currently comprises 27 operational spacecraft, including one of the new next-generation GLONASS K series, which is still undergoing space flight tests. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that Beijing's decision to cover up the true extent of the dangers posed by the COVID-19 coronavirus may have directly led to the death of up to 25,000 people. The findings, reported by the University of Southampton, show that 95% of deaths could have been avoided if China's communist government hadn't tried to hide what was really going on. Scientists found that COVID-19 cases could have been reduced by 66% if measures had been taken a week earlier, and by 86% if the action had begun 2 weeks earlier. Meanwhile, a fifth Wuhan doctor who was arrested by the Chinese government after trying to warn the world about the dangers posed by the COVID-19 virus has now died. And like all the others, Beijing claims he died from the disease. Medical experts have discovered that a sudden loss of smell could be the first sign that you've been infected with COVID-19. The discovery was reported simultaneously by ear, nose and throat specialists in several countries. They found the loss of smell occurs as the virus causes swelling in the olfactory mucosa. This appears to be more likely to happen to those with COVID-19 than other viruses, and may be a key clinical indicator in otherwise symptom-free carriers of the virus. A new study has found that East Antarctica's Denman Glacier has retreated 5 kilometers in the past 22 years. The findings, reported in the journal Geophysical Research Letters, has raised concerns among scientists that the shape of the ground surface beneath the ice sheet could make it even more susceptible to climate change-driven collapse. The findings are based on the most complete and detailed examination of the glacier and its surrounding area ever undertaken. The authors found that the glacier has lost 268 billion tons of ice between 1979 and 2017. If fully thawed, the ice in Denman would cause sea levels worldwide to rise by about 1.5 meters or 5 feet. A new study claims boys hitting puberty at an early age are more likely to develop type 2 diabetes as adults. The findings, reported in the journal Diabetologia, show that irrespective of their weight, boys getting their squeaky voices between the ages of 9.3 and 13.4 years were around twice as likely to develop early type 2 diabetes later on compared to those who reached puberty between the ages of 14.8 and 17.9 years. Although it's a little different for everyone, boys normally reach puberty around the age of 12 or 13, with a transformation usually taking up to around 4 years. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.